Well, good evening. We are about to start the last session of today, which will be actually the most interesting one because of these excellent speakers. And I would like to thank the organizers of this ABS for inviting me here to be the facilitator in this session, and I will be very happy to launch the first questions. Having heard the previous presentations, which were of utmost interest, it is quite clear that we are already used to the idea that a single magical BIM software does not exist. It is needless to say in this forum, but this concept is quite difficult for clients to understand. I think this session is very well structured because we are going to talk in three different stages, or we're going to talk about apps in three different stages that relate to a real BIM affecting the whole life cycle of a building. Definitely, we will need new software, new apps, etc. I believe that the way this session has been structured will illustrate this quite nicely. We will begin with Rhino and Grasshopper. Afterwards, we have the speaker from Controsoft, who will be approaching the real industrialization of construction, very important, and how to construct or fabricate structures in this case. And finally, our last speaker from the company Final Cut will be talking about a very relevant topic for construction works, which are mobile apps to optimize and enhance the construction process on site. So thanks again, and thanks Francesc Saya from the company Visual Art. He is an architecture and manager and project manager at the company Asuni, among them Visual Art, which is the one he's going to talk about. Well, thank you very much, Oscar, and also to the organizers for allowing me to be here and to share with you Visual Arc. It's a program based on Rhino, and I'm sure many of you are already familiar with it, and also Grasshopper. For those who don't know Rhino is a 3D modeling platform that it is useful for other developers to add more apps and functions. These may be apps for architecture, imaging, anything. Basically, Rhino is used in very different fields, from industrial design, boats, jewelry, cars, furniture, animation, shoe wear. So it goes from very small objects such as jewelry up to huge projects such as a building. So here you can see these functionalities of this platform that allows you to extract all the documentation regarding a project. Why BIM? Well, because it comprises all the documentation, and all the documents are generated by or based on 3D models. Also, parametrical architecture objects, so we can list them and know how many of them are there, the volume, sizes, and so on, and to add new information on each of them. It is more practical to work with these parametrical objects and say, I want it to be 3 meters long and not 4 meters long. And this is an improvement. Also, Rhino allows for model exchange through the ASC format or IFC format. I'm sure you are already familiar with that. So you export that to the IFC, and Revit identifies columns and models as native. So the workflow is very useful to begin modeling in a very agile way and for more complex models in Rhino, and to translate them to Revit so that other teams can work on them. Why do we talk about flexible BIM? Because we work with flexible and complex shapes. With very few control points, we get full precision. So this is used in construction for modeling shapes that are later 3D printed. And it's also very useful for complex geometries. Flexible also, actually, for the ones not familiar with Grasshopper, is a visual algorithmical editor, and Visual Arc is integrated in Grasshopper. All the objects of Visual Arc can be created from Grasshopper. In this example, you can see a routine, a general routine in Grasshopper, and from a solid you get the height, and it's divided into a number of points. A plan is set into each point and generates an intersection with the original solid. From here you get the lines around this object, and this means that in a very simple way we can divide a solid object into different levels or stages or floors. And you can create your own tools and routines of this kind of geometry. So the power of Grasshopper is huge when it comes to modeling. I will be showing some live examples for you to get a better impression on that. Another useful function in terms of IFC, on the one hand, we have normal objects such as walls and partitioning, but we can also create solids as this one, which has a more complex shape, and at any time you can assign information and data to that, like make it a forge, for instance. So we can say that this has been a forge. We add a kind of comment or tag, and later on you can retrieve this information. So this applies not also to objects per se, but also to any kinds of geometry in Rhino. Also, it is available, or it has available all CAD or 2D tools. And finally, all the tools for architecture, visualization, renderizations, and photorealistic visualizations. One of Rhino applications is to elevate these models for 3D printing. And at the end of the day, what you need is a closed surface, a closed solid, so that the machine reads it as such. And of course, Visual Arc objects can be converted. And with a Boolean union, you can convert them through the SLP format, which is the most practical, and bring it to the 3D printer. I would like to show you some of the novelties that we recently launched, because I believe them to be really, really handy, especially if you work with Rhino and different levels. This gives you the ability to show or hide stages, for instance, and at the same time to work with sections. So you can put some sections, make some sections active and hide some others, and to be more interactive. Then to draw plans, and we have added the function to directly print these plans and sketches. So you set, for instance, a 3D view, and you can print this in a good quality. I would like to highlight, especially in this new feature related to integration to Grasshopper, that is the ability to create these architectural objects from Grasshopper. So to translate and transfer this flexibility through the dialogues of Visual Arc for them to be more user-friendly and to have a vast library of objects. We continuously add new objects, both in 3D objects and on paper or 2D. And what I said at the beginning, to the possibility to add any kind of information to any objects and create new parameters such as the price, the provider, or technical transmission coefficient, and so on. So anything you want to invent or create, you can just complete these objects with further information. I would like to show you some real cases completed with Rhino and Grasshopper, which at the same time have two very different platforms. The first one is a project on an existing building in Italy, where this building was scanned through a 3D scanner. They obtained the point cloud through a plugin of Rhino, and with the Visual Arc objects, the model was built to get a BIM model that would be delivered to the client, which in that case was the town hall of the municipality of this lighthouse. And well, actually, the rest of it comes in automatically. Another example, changing the scale and the kind of project, this pavilion in Norway, which shows quite clearly the whole process from the design. Grasshopper is quite widely used in design. Through different values and parameters, you can actually get the information of other components, also to draw diagrams to optimize the construction. Here are some views of this pavilion. We applied Visual Arc to get all the plans and sketches, some pictures on the construction process and the final. And another example, that's a church in Croatia, which is currently under construction, and that was created completely in Rhino and Visual Arc. So we were able to work at different heights and stages. So for the architects, Bionics, it was extremely useful. They could assign different kinds of partitioning and walls. They worked with the whole, at different levels, as I said, with the corresponding graphical representation. Here we can see some comparisons between the reality and the graphical views. And the last one. Well, if you wish to know further information, you can visit our website or contact me. I have 5 minutes left, and during this time, I would like to show you the software and the program live. I know that real-time or live demonstrations are quite dangerous, especially because I'm going to show you a beta phase of this software, but I would like you to give a little taste of this program. That would be the Rhino interface. You see all the objects that Visual Arc adds to Rhino, and tools very useful, such as the possibility to work at different levels and stages, to hide or add new stages as you wish. And this offers a really interesting view of the project, also very user-friendly. Here I have a door, I can move it around, change its location, etc. I double-click to change the floor I want to show. And if I work from this view, see that it seems like a 2D representation, but it's not. So this top view actually makes our life very easy. There's also a section administrator or manager. So we set define the different regions and sections, and we can change and switch from one to the other. And then here we prepare the different floors on paper, and we can choose which floor do we want to show, the ground floor, first floor, etc. The same works and applies to sections, let's say section B or section A or C. We don't have to worry anymore about the 3D in these views. And finally, I would like to show this integration to Grasshopper that we currently develop. So I open Grasshopper. And this garage door, for instance, this door cannot be created by Visual Arc. There's an option which is to assign 3D blocks to certain objects. But this block is a static one, it's not parametrical. In this case, it's a garage door, and if you want to have it, you have to use Rhino or to create some blocks. So what we have done is to develop the possibility to create it on Grasshopper. Here we set the width and the height, the opening. So that would be the input values. And finally, we have two geographical components, the leaves and the frame. I click on save this definition. And now I create a new door style. Here you can see that there's a conventional door and the option to create this door from Grasshopper. So I select the file that I just saved. Actually, this geometry is created by Grasshopper from behind, even though we don't see it, and the geometrical components that we included in the definition. Here, there's a list of all the parameters that define this object, and to each of them, we can choose if they are editable by definition, style, or object, or just hide them, because some of them are just figure related and not interesting to any particular case. So once we have this object, or once we complete this process, this object is at our disposal, and therefore we can just include it in our model. We can take a look at its properties, and we'll see that the properties are the same that we define for the object. And we can modify it if we wish. So this provides us with full flexibility to create any objects that we want in a freely manner and with no design constraints. So I have no more time left. Thank you very much for your attention, and thank you very much.
La verdad que ha estado perfecto.
Well, you were perfectly on time. And since we are changing laptops, I'm going to introduce myself because I didn't want to use the time of our speakers. My name is Oscar Liébana. I'm an architectural director and civil engineer at the European University in Madrid. So I have a rather academic profile. And I also belong to a virtual association of trainers and educators that work with BIM. I believe that these applications and software are needed in order to avoid that BIM is associated to construction only. And I think that this kind of tools, such as Rhino and Grasshopper, and so reflect what should happen in reality, that BIM is applied in the design phase, but also to the construction. I think the mindset in universities is starting to change and to shift. And I think that for students, it is much easier to use several softwares and plugins and so on. So it's not actually a problem for them. Okay, I'm going to keep myself short. Well, actually, being myself a lecturer for structures, the next presentation is the topic I am very familiar with. José Cosculluela is an engineer in construction and also a partner of the Construsoft group. He's been working for many, many years in this sector. He worked he was in Stanford, and I think that he contributed to this change in the mindset, which is the reality of structures in building, in concrete on site. Thank you very much, Oscar.
Well, I feel like at home here. I am actually from Barcelona, and in Chile it's really cold right now. That's where I live, so I feel really well in Barcelona. Thank you for being here, for choosing our talk. And I wanted to ask you something. How many of you work in a construction company directly? You can raise up your hands. And as subcontractors, how many of you are subcontractors of a construction company? Okay. Construsoft. Well, you can say we didn't really put much effort in the name of the company, but the company, the equipment is really good. The team is even better, and many of you know Construsoft by Tecla. We have always been related to the structure sector. There are three parts. We have been working with BIM from 1995, even before that the actual BIM denomination was created. We work with models, that's Tecla. The part of managing structures, that's Tecla. The part that deals with 4D and 5D is BICO. And then we have also added another software in our portfolio for industrial plants, that's Catmatic. Okay. We have six things I would like to talk with you about. Do you think that BIM and productivity go together? Is it the same? If I work with BIM, I'm more productive? We'll talk about it later. We will also analyze a very simple work site. The following question is, who must perform the model? And most importantly, who must pay for it? We have offices in Lima, Bogota, Santiago de Chile, Barcelona, Madrid, and many clients say, well, we are not paid for this, who should do that? And many times we don't really talk about the model, who should pay for the model. We will also talk about, Oscar actually mentioned, I got a certification from Stanford in VDC, and Martin Fisher, who was a professor of mine in Stanford, will be here tomorrow. You cannot miss his presentation. So we will talk about how we work with virtual design construction. Also, we will talk about information for the construction company, and we will also cover some already performed experiences in America. So let's cut the chase. BIM and productivity. The Chilean government actually carried out an analysis, and we see the blue horizontal line. We see that productivity does not really grow, but other sectors are growing. So why we do not have more productivity in construction, but they do have more productivity in other sectors? Then they compared to the States, to the United States. In 2007, we assumed that if the United States had 100 units, Chile had 55. We checked again in 2011, and we went from 55 to 48. And they wondered, why is this happening? The conclusions is that we need to prefabricate, and also they concluded that if information is segmented and fragmented, it does not work. So if you use any platform, the coolest 3D system, but you end up working with paper, you will have the same productivity as 50 years ago. Maybe, yes, you'll get better products, but the productivity will be pretty much the same. So if we use paper in any of the stages, we are back to the same productivity as 50 years ago. We are part of a task group for the government, and we need to go from the image on the left to the image on the right. Let's focus now in a very complicated and complex project. Think about it. Okay, there we go. This is a home center such as the IKEA furniture. I put that together with my mother-in-law. We got along really well, so it was not really a risky project. But, you know, after we finished, I needed to have exploded drawing and also mounting instructions. Without the instructions, maybe we wouldn't have been able to do that. So imagine, if we need all the instructions very detailed for such a small thing, don't you think I will need the same for a hospital, for building a hospital, an airport, or for building anything? And the answer is yes. Do we have it? The answer is no. So basically, we are reaching a compatibilization model. We have a clash detection system. That's great. But it's like if we only had the 3D model for the furniture we put together. We also need the bolts and we need the mounting instructions. We think that the traditional BIM is cool. The platforms that are doing that are great, but we need to move further. We need to go beyond that. We need to have more detail. Maybe we can reach up to the level 400, 450, so that we have all the information and it goes from the model to the machine. Then we will change our productivity when compared to paper. So I would like to have the eye of BIM, not only for information, but also for industrialization. That's the workflow. Tomorrow we'll hear about similar things, but when we talk about the 300 level, we are doing the traditional BIM. As I was saying, we think that this is what we need to achieve, this part on screen, where the subcontractor works at a very detailed level that allows us to bring the fabricated piece with a code bar so that we can just put that in the right place and we will be very more productive. So we will have all the embeds, all the installations, all the MEP, all the reinforcing steel, or the anchors, all the revers. If we have all this information, we not only have the information from the beginning, but we have all the information we need to plan the work the best way. Also, in the United States, they have the BIM to fill that gives us some layout points to check if the BIM is well used or not. For many years, our softwares have dealt with this structure, but for any specialty, we need to do the same. We need to achieve a constructible model, and hopefully also an industrializable one. From the model, we are able to reach to the point where we can build the different components. A person can do 50 of these pieces a day, but the machine does several per second. For example, we can also have other clients in the steel industry. In this industry, each machine is connected with Tecla, and then when we start working with the machine, we see that the machine knows already what needs to be done, and it's very precise. It's almost playing with Lego. Also, when we work with prefabricated concrete, it works as well. In the past, we worked with paper, but now we're working with different prefabricated elements. So we listen to the diagnosis that has been done in several countries so that we have a larger productivity. Here, for example, we know where the piece goes. We just put it together, we mount it together, and that's perfect. The on-site work can last months, but the prefabricated work can just last some days. So who pays for these? If we industrialize, we're more productive. and it will work out fine. But who pays for that and who carries out all the work? We have three possibilities: the engineering company, the provider, or the subcontractor. Sometimes we have the engineering company and they do very high quality projects and we're done. But what happens is that many times the engineering companies say that they are not paid for that, so they don't want to do it. The construction company needs to have information to work faster, and also the industrial needs to have information to work faster. So who pays for it? Some countries, like the United States, the situation is that the contractor pays for it willingly. But in our country, for example, in Spain, we don't do it this way. Maybe we have the money to do the clash check, but that's pretty much it. So with construction companies, we see that 75% of the money goes to subcontractors. And it could make sense to say, I will pay you as much money, but I don't only want the project, I want the model, and I want to be well performed, and I want to show how your product was done. And that model will be useful for me to create other projects. In the countries where this is done, this works great. So we think that it could be a good idea that the subcontractor does this work, not as an additional service, but just as a added value. Do you think that could work? After that, the construction company gets many advantages because they have all the value. This is what they do is not a model different from what was done at the beginning. It's a very well performed model. Afterwards, I can do a really good planning. And just by using code bars, I will know where each piece goes. I will also be able to plan. I will know what is needed every day on site. And I can also do that with a 4D tool. I can also plan when I will have the concrete trucks coming. And I will know where the reinforced concrete must go. The rebar is also important. I'm running out of time and I still have a lot to say. So with the rebar, if I know where each rebar goes, I will not lose any part. So what we do, the idea is that we need to have everything really well defined, so I can just put the pieces together like when we play with Lego. With pouring, well, we see that here I can determine what I'm going to pour every day. Also with rebars, instead of having papers that really do not give me much information on where each element goes, these rebars will show me a lot of information, and we are saving a lot of money. For example, here we have the production workflow from the modeling up until the just-in-time delivery of the material we need with the quality we need and at the moment we need it. So, based on the Stanford system, we start with a clash detection. We do the modeling and we will have all these specialties. We need to make sure that everything is working out fine. Once we are there, we need to make it compatible. We will have the RFI. And just a little piece of advice. We are working in 15, 16 projects right now as consultants. So we need to have the industrial company come and talk to you. We need to have all the different stakeholders, and they need to talk and make decisions about some clashes that will cost a lot of money. And then we need to decide how everything needs to be produced and who will be better. That means more productivity. And remember, we're not talking about drawings, actually. Tomorrow, Martin will talk about some very collaborative meetings, everyone there saying their own opinion about the workflow and industrializable material. This way, we will have all the different elements so that we can order the material the way that works better for us. Let's forget about paper. Let's have also the industrial company that will bring their components and they bring it to us so that we can put each piece together when we want to use it. The model needs to get on site, otherwise it's useless. Can I get a couple more minutes? Okay. So we're not talking only about structure. I also want to show you how the MEP and all the prefabricated stages help us here. This is what our clients do. This is what the construction company must demand to the subcontractors. This is the way you need to work and that you will hear about tomorrow. As associated information to the model, we will make some decisions on construction, but we also need, let's see this Excel sheet, let's zoom in, but you will see that I have marked 2 columns in yellow. That's where the dates of when each stage is completed. And at the same time, we also need to know about the logistics. We need to get information about the model, on-site and real. So we need to go to the actual on-site with the model. And finally, I will say this is a cross-cutting process. Well, you will see this is not the piece of furniture we were doing, but we can use it to different uses. This is an office building. This is an ongoing construction work that we are doing in Lima. This is by a head cliff. And we're building this hotel starting from the model. We're working from the model. We also have a nuclear plant in France. So this is a cross-cutting process and project. This is also part of the Santiago airport. And the idea is to have real coordination among specialties. And someone needs to do the model so that the construction company can take it to the work site. You are invited to check more on this in our stand outside the room. Thank you.
Muchas gracias.
Thank you very much. And finally, last but not least, and in order to close the loop, we've talked about industrialization, and of course, industrialization will have an important role in our next session or speech, because we are going to talk about the apps and other features that people will need on site. So I'm going to introduce Aurelian Blaha, who's the marketing director of Final Cut, who's going to talk mostly on mobile devices.
To speak here, thanks especially to Ignacy, and thank you everyone for being here for the last session of the day. I promise I will be short. So our topic today is how to bring BIM to the field, to people on the field, to everyone involved during the construction, on the construction site. I'm Aurélien Ballard, I'm marketing director with Final Cut. Our mission is to change the way we build with mobile apps for anyone involved in the field, including contractors, subcontractors, architects, and developers. If you think about it, we all have mobile apps today in our pockets, on smartphones, on tablets. We all use apps like Airbnb, Uber, Waze, such as this one. And the success of those apps is really massive. Why? Because there's massive adoption. All of us are using them. Why is there massive adoption? Because they are very well designed. They're very easy to use. With something like Waze, you just enter an address, and it will tell you at what time you will arrive. Now imagine you have a mobile app where you put your BIM model on it, and it will tell you when you will deliver the building. Wouldn't that be great, right? The problem with professional apps is that they are not as well designed and as user-friendly as the apps we use at home. Why is so? Why at work we shouldn't have the ability to have such beautifully designed apps as we have at home, right? So the whole question is how to bring BIM onto the field for anyone to use, if we don't want to have this digital divide between engineers and architects that are using BIM in the office for the design phase, and people on the field who actually build the building or the infrastructure, why should it be out of this digital transformation? But of course, BIM is complex, and bringing BIM to the field is not easy. So what I want to share with you today is a few rules that we've applied to ourselves to make sure that BIM can be used by anyone, and in a way that is so simple and can be used by anyone. So the whole question is how to bring this virtual model that has been designed to the field. Why is it interesting? Because to avoid this digital divide between the design and the construction, you might have a beautiful design in the BIM model in the design phase. If you go back to paper blueprints in the construction phase, it's almost everything lost. And then there's another divide between the construction phase and the facility management when there is no data of the asset. There's no history. The contractor, his only thing that he thinks about is his next project. And the facility manager has to find out where here is leaking, here is breaking, and there's no traceability, there's no history. So taking the advantage, the opportunity of the construction phase, which is in the middle, to track the changes is very key to have a consistent virtual twin, digital twin, if you prefer, all along the stages. So rule number one is we focus on the job. There's a lot of applications on the market for BIM on tablets or smartphones. The problem is that they bring the whole model. So it's great for architects because the architect knows his own baby, he knows how to play with the project and everything, but for people on the field, this is way too complicated. So what we do is we pre-filter, we pre-select elements of interest for a given phase, for a given stakeholder at a given time. So for instance, here for structural work, let's assume we have to do quality control on those pillars. We will select the pillars one by one for them to be able to do the quality control with the why questions, like is it compliant, is the implementation has been respected, the dimensions are okay, the material is okay, and so on. So the way we do that, we've developed plugins on Revit that will ultimately select all the objects and create the associated quality control or progress monitoring processes that can be used directly on the mobile app, and then that can generate data analytics and reports. Rule number two is to use metaphors. If we look at the way people are using paper blueprints today, a common way is to follow the progress. It's to use those Stabilo bus pens with red when it's not compliant, or green when it's done, or yellow when it's in progress. We did the same thing on the BIM model. So on the BIM model, you can follow the quality control, or you can follow the progress using the same metaphor as a Stabilo on the blueprint here, except that it's on the BIM model directly, and of course you can generate reports in the same way. And of course, all of this is sent back to the BIM model, back to the office, where the BIM manager can follow over time and reconcile as built with as design. Rule number three is to try every time we can to make it really, really simple. So I'll show you three examples. The first one is we've been using QR codes because in most buildings, especially housing or here it's a hospital, all the rooms or all the housing units are looking like each other. So it's really a pain to get sorted where you are. So here you just flash the QR code, and boom, you're instantly brought to the right blueprint or the right model. Another one we developed is we got inspiration from what you have on your smartphone. When you take pictures of people, it automatically recognizes the face of people. We did this, we used the same algorithm, this deep learning algorithm, to recognize objects of a building. The advantage is that it will do predictive analytics on what is the most frequent corrective action associated to that object. So for instance, here with a security block, it would be probably replace or change or fix it. So you have, like, you type in Google suggest, you have suggestions, and shows what are the most corrective actions. So really simplifying the work. And the last example is, instead of having the defects on a blueprint or a BIM model, we developed with Google Tango technology, which is an infrared technology, and Flux.io, we developed an app where you can directly see with augmented reality and put the defects that you're spotting directly within the app. So from there, I mean, you don't even need to know how to read a drawing or a BIM model. You just point where the defects are. So it's quite, it's really, I don't see what we could do more simple than that. So really bringing, and of course this goes back to the BIM model. So really make sure that this is as easy to use as it can be. Now the thing is, in theory, BIM is about design, construction phase, and facility management. The truth is that as of today, BIM is still most of the time stuck in the design phase. It struggles to go down to the construction phase and then forward. But this is changing. We did a survey between March 2016 and March 2017, and we found that actually that the adoption is coming. We asked people from especially contractors and subcontractors, are you using BIM during the construction phase? And you can see that the trend is moving up in terms of adoption, and of course the people who are not using it is going down. So it's really happening now. So are you ready to put boots on BIM? And as we say, we use Waze to drive today, and tomorrow we'll use Final CAD to build. Thank you very much. Oh, one last thing. We're looking for Spanish partners. So if anyone in the room is interested to help us in Spain, much welcome. Thank you.
Ya sabéis, si alguien quiere ser socio. Bueno, muchas gracias.
Well, thank you very much for this presentation. That will be the last one, and we are going to close this final session. If the audience has any question, we have about 5 minutes left. Otherwise, I am going to ask something. Well, a general question for the three speakers. What do you think, since we have talked about software, different stages and phases, and also the life cycle of a building, what do you think about interoperability among them and the use of IFC? And how do you think that this typical problem is currently shifting, the problem we have from the designers up to the construction? So the floor is yours. Well, in our case, many users use IFC to model in Rhino, and then they need the IFC model for other software. I would say the IFC is the one providing them the large number of solutions, but it's not 100% useful. So it has still some constraints and limitations because every client uses different parameters, and sometimes this communication is not full. IFC is really necessary, and also it's very good. Perfect? No. Very good? Yes. We have actually answered about 45,000 questions regarding technical support, and many of them are related to the IFC. And I wonder myself if they have actually taken a look at the specificities of IFC. You have to take some time and take a deeper look of that. In the airport of Santiago de Chile, There have been some small areas and logical pieces such as the pilots and the slabs, and to see if the areas are well or not. Maybe we are about 10% wrong, but I think that the IFC is good and necessary, and it also ensures that if a software developer disappears, IFC is going to be there always. And also, if you allow me to give you some piece of advice, take courses on multi-platforms, which means courses not based just in one platform, but different platforms. If so, you will have you won't be fearing anything. And as I said, IFC works quite well, not perfectly, but quite well.
Durability. Do you know what? I don't know, in mobile apps.
Yes,
do you know?
yes, of course. Yeah, I mentioned Revit because I mean we're a small organization, so we go on the opportunity line, right? So Revit is by far we get 80% of the projects with Revit, so that's why we choose to integrate directly with Revit. Anything outside, we use, of course, IFC. So the level of detail that we get in the end is a bit lower, of course. But of course, we can use IFC to get the model on the tablet. And then for the way back to the model, we use the BCF, the BIM collaboration format, which is, the metaphor is often the sticky notes on the objects, which is very lightweight and very suited to the kind of information we get on the ground, such as pictures, comments, dates. And then we get this back up to the BIM model back in the office, and then the BIM manager has the opportunity to change the model according to what has been built.
Muy bien. Muchas gracias.
Well, thank you very much. I don't know if there's any question left or want to say something else about IFC. Building Smart recommended us to talk about this, but I think that IFC is more and more relevant regarding the use of software and apps. So thank you very much to all of you, and see you tomorrow.